Hello.
Hello.
Yeah. Can you hear me?
Yeah.
Okay. So let's start. Which problem sets have you done? Which paper?
I did 2020 AMC 10B.
Okay. Tell me which question was it issue?
Uh, I did like 15 to 25, and the first one I didn't get was problem 20.
Yeah. Right. So D is a right rectangular prism with
Mm-hmm.
edges of length 1, 3, and 4 together
Yeah.
with its interior. For real R greater than equal to 0, let SR be the set of points in 3D space that lie within a distance r of some point in B. Okay, volume of SR can be written as this cubic expression. You have to find BC by AD.
Yeah.
Okay, fine. So it's a right rectangular prism or a box, he's saying.
Yes.
Okay. So there are three edges, 1, 3, and 4. That those can be your length, breadth, and height.
Yes.
For real r greater than equal to 0, SR is the set of points in 3D space that lie within a distance r of some point in B, some point inside B.
Yeah.
Volume of SR can be written as a cubic. Okay, right. So this is like a box. 1, 3, and 4 are the side lengths. So we can say height is 1 and this is 3 and this is 4. And S of R is the set of points which is at a distance within a distance R of some point in B. So total volume here is 12.
Yes.
Within R distance of a point. Okay. Right. So Basically, the points could be on the surface of the box as well, and they could be inside the box also. And you need to figure out where, what is the total volume of that region in all directions. So, okay, so imagine if the point is at a distance r but above, right, from this surface. So technically, there will be a portion of the volume which is above this, right? So from this face, what you can do is you can say r distance above. The point could be inside that volume also, right? From
Yeah.
from each face, you could be outside also actually, right? Within
Yes.
r of a point, within r distance of a point in the box, right?
Right.
So if you focus on each face, technically all of the faces will add up to the surface area of the box. Surface area of box plus that extra r distance, right? So the volume required would be surface area times r, right?
Right.
Because it could be outside the box also, actually.
Yeah.
So that is one place where the point could be. So that would be surface area, which is twice of L into B plus B into H plus H into L. So twice of 3 plus 4 plus 12. 3 plus 4, 7 plus 12, 19 into 2, 38. 38 R is the required volume here, right? So
Yeah.
no matter how the box is, the point could be outside the box at a distance of R from the surface of the box, right? So that is what we are writing here. It could also
Oh,
be inside the box. That volume would be 12, right?
yeah.
So far we have gotten two terms, by the way. This 12 and this 38 R, right?
Right.
Do you understand what I'm saying?
Yes.
However, that is not all because there are other situations like right now we just went R distance above one surface, but we have not explored what would happen if you were on this edge, right? Like,
Yes.
because we went above the face, right? We went above this face. We didn't think of around this edge, right?
Right.
Do you understand what I'm saying?
Yes, yes, I understand.
The point here could be at a r distance from this edge. So you can sort of draw a circle like this, right?
Yeah.
All along the edge, no?
Yeah.
So that will give us like a cylinder type of situation, no? Because the edge will become the axis of that cylinder.
Right. Yeah.
So if you think of a line like this, how much of the cylinder will it be? That's what we have to figure out. So uh, there is a cylindrical circular thing, but we only want to capture the area that has not covered in the first two terms, right?
Yeah.
So this is like a quarter cylinder. After that, if you go like beyond this, I think we have already covered it because our distance above, we have already captured the box, right?
Right.
Do you understand what I'm saying?
Yes, yes.
So technically only this part is the extra part which we didn't capture when we went R above the face, right?
Yeah.
So this is like a quarter cylinder, right?
Right.
So quarter cylinder's volume we have to find, right? So 1 by 4 into pi r square into h, right? And this h would be the length of this edge, right?
Right.
Do you understand what I'm saying?
Yeah.
You have to do this for all the edges, right?
Yes.
Correct? So
Yeah.
there are 12 edges. Uh, 4 edges have length 1, 4 edges have length 3, and 4 edges have length 4, right?
Yeah.
So 4 times 1 by 4 pi into 1 pi into r square into 1, and 4 times 1 by 4 pi into r square into 3, and 4 times 1 by 4 pi into r square into 4, right?
Yeah.
So this all gets cancelled and you have 1 plus 3, 8 pi r square, right?
Right.
Do you understand what I'm saying right now?
Yes, yes, yes.
So far the volume has become the inside the thing volume was 12. After that, just above it, all along each face, we got the volume to be multiply the surface area with this. So you got 38 R, right?
Yeah.
Now along each edge, we made this cylinder and this portion was not yet covered, right? So that for everyone, it is a quarter cylinder and it became 8 pi R square, right?
Yes.
And now the final thing that is still not covered is what happens if the point is on the vertex, each vertex of the box, right?
Uh-huh.
Imagine the point is on the vertex here. We have covered most of the volume that is required, but there is still some volume towards the outer edge. Like technically, there is a sphere of radius r, right? Sphere
Yeah.
of radius r all around the vertex, right?
Right.
But out of this sphere, some parts of it are already captured. For example, everything inside is done. Everything slightly above here on the face is done, right? Even the quarter cylinder part is done, right?
Yes.
So if you imagine quarter cylinder here along this, quarter cylinder along this one, quarter cylinder along this one are done, but there is still some portion of the volume here
Yeah.
that is not captured in any way. So you need to visualize it properly. Uh, Best way to visualize it would be to think of it on the XYZ plane and think of the point here. Let's say the sphere was, body was like this. Let's say this is 3 units. Let's say this is 4 units. And let's say it goes up by 1 units, right?
Mhm.
This was my body, right?
Yeah.
And let's say this is X, Y, and Z, right?
Right.
Now, what I'm saying is around this point 0, comma 0, there is a sphere of radius r in all three directions, right?
Yeah.
So far, I have uh, I have captured the quarter cylinder on the outside, the on the negative z-axis side, right? Like this, along every point on this edge, right?
Yeah.
I have also captured the the layer that is below it by distance r around this whole face, right?
Right.
But if you just focus on one point, for example, here on each vertex, it's actually a sphere of radius r. No, there is some portion that is not yet captured. Like if you
Right.
put a sphere on the corner of radius r, there will be a little bit of a portion that is not covered so far. Do you understand? The whole sphere is not yet captured in all of the areas that we have done.
Yeah.
So you have to realize what portion of the sphere is not yet covered, right? So only if you realize that will we be able to do it. Uh, there are actually how many corner points? There are 8 corners, right? One
Yes.
here, one here, one here, one here, and similarly 4 below, right?
Yeah.
8 corners, and we only care about the region outside of the sphere that was not yet captured, right?
Yes.
So it should be 1/8 of the sphere on each corner.
Correct.
It can't be 1/4 of the sphere. That doesn't make sense because 1/4 of the sphere will already be on that edge. Like these portions are already done. When we did the cylinder, along each edge, we did a cylinder. So some of the portions are already covered here. Uh, I think it is 1/8 of the sphere. If you choose 1/8 of the sphere at each corner, it will be 8 times 1/8 of the sphere, right? So 8 times 1/8 of 4 by 3 pi r cube, right?
Yeah.
Because there are 8 of them, so you'll get 4 by 3 pi r cube. That becomes the volume, extra volume that is left over here. And now you add all the terms, you get the second term was what? We got how much r square? We got 8 pi r square, right?
Yeah.
And we got 38 r and we got 12. These are the
Yeah.
volumes that are there. Now this was A, B, C, D. So A for us is 4 by 3 pi, B is 8 pi, C is 38, and D is 12. And the question is asking us to calculate what? BC by AD. BC by AD is going to become 8 pi into 38 divided by 4 by 3 pi into 12. So pi gets cancelled. This becomes a 16 and this becomes by 2. So this is 19. BC by AD value is coming out to be 19. See, a better way to do it would be to try to visualize it. So I'm sure like there will be ways to visualize it. One second. Can possibly find a nice visualization of it online. You should search the problem and try to find a way to see the shape that is being discussed. Okay.
Yeah.
I can, if I find a link, I'll send it to you. But basically, the point is you want r distance away from anywhere on the surface, right? So the first part is obvious, which is just take the surface area and go r above, right?
Yeah.
The second part is also obvious, which is along each edge, right?
Right.
And Third part is the slightly tricky one along the corner vertex, right? How much is still not covered, right?
Yes.
And the constant term is what is inside the box, which is fine, which is 12, right?
Yes.
So that is what we have to do here. Let's go to the next one. Which one is the problem next?
The next one, problem 21.
Okay. Uh, ABCD is a square, that one, right?
Yeah.
Okay. In a square ABCD, points E and H lie on AB and DA respectively, so that AE is equal to AH. Points F and G lie on BC and CD respectively, and points I and J lie on EH, so that FI is perpendicular to EH and GJ is perpendicular to EH. So basically FI and GJ are parallel lines. The figure has been shown. The triangle AEH, quadrilateral BFIE, okay, quadrilateral DHGJ, and pentagon FC FCGJI. All of them has area 1. What is FI square? Okay. Okay, the figure has been given to you. So from there you have to figure out. So let's draw the figure ABCD. AE is equal to AH, something like this. So this is E and this is H, and you have to join these. And then the question said there was G and F here, and you drop perpendiculars on here, right?
Yeah.
These are J and I, and the areas were given to be 1 for 3 figures. Triangle AEH, 4 things actually. Triangle AEH, quadrilateral BFIE. So this triangle, BFI, this quadrilateral, this pentagon, and also DHGJ, this also. So technically, all the areas are 1, 1, 1, and 1, right?
Right.
So the
Yeah.
whole figure has area 4. So that means
Yes.
each side has length 2.
Yeah.
You have to find out FI square. FI
Right.
square. Okay. Uh, Fine. Right. So they have also told us AH is equal to AE.
Yeah.
So this is an isosceles triangle and area is 1, and it's a right angle triangle also. So
Yeah.
half into x is 1. So x square is 2. So x is root 2. This is root
Yes.
2. This is root 2. So we know this much would be 2 minus root 2. And this much would be also 2 minus root 2. Right?
Yes.
Okay. Uh, Right. Hmm. So to find Fi square. So what can we find about this triangle? We know the area, we know the sides, we know the length HE now, right? Would
Yeah.
be length of HE would be root over 2 plus 2, right?
Yeah.
So it is 2 length.
Yeah.
If I connect the diagonal of the square, notice that the diagonal of the square will be actually AC diagonal, and it would be perpendicular to this, right?
Yeah.
HE, and therefore it will be parallel to GJ and IF also.
Right.
Something like this.
Yeah.
The length of the diagonal, this part, we can find by doing area. Half into this part length into HE length is same as the area of AHE, right?
Yeah.
So half into X into HE's length is 2 is equal to area of AHE, which is 1. So this part is 1, right?
Yeah.
This part is 1, then this part would come for us, right? Because the overall diagonal would be 2 root 2, right?
Right.
Do you understand what I'm saying?
Yeah.
So this part here is going to be 2 root 2 minus 1, right?
Yes.
Right. So 2 root 2 minus 1, and the point here would be such that it will be the midpoint of J and I. The situation is symmetrical because this area and this area are equal. So, and these lines are parallel. So our diagonal should bisect this whole portion, right?
Right.
Do you understand what I'm saying?
Yes.
So basically, I'm getting CM length is equal to this, right?
Right.
Okay. Uh, we join this and we call this point as N. This makes us a rectangle, and this N will be midpoint of FG also, right? So I want to find out this X, which is NC, okay?
Yeah.
Because if I know that, then I'll know MN, and MN
Right.
will be same as FI, right?
Yes.
So all I need is find out this X because I already know MC is 2 root 2 minus 1, right?
Yes.
Okay. So let's think about, can we find out the MC, NC? So by the way, from the pattern in this side, we got this length as 1 and HE as 2, right?
Yes.
Notice we did the calculations. HE was having length 2, then this length was 1. So if this is x, then this is 2x, right?
Yes.
Because it's the same symmetrical pattern. So if NC is x, then FG is 2x.
Right.
Correct? Uh,
Yes.
the area of the pentagon, if you think of, the pentagon was CGJIF, right?
Yes.
The area of the pentagon would be the triangle plus the rectangle, right? Correct?
Yes.
The CGF triangle plus the rectangle. So it would be, we are saying that if this is x and this is 2x, we know this one and this one should be root 2x and root 2x, right?
Right.
Then only this, by Pythagoras theorem, this one will be 2x, no?
Yeah, yeah, yeah.
So area of the triangle is half into root 2x into root 2x plus area of the rectangle, right?
Right.
Area of the rectangle would be GF into FI, right?
Yes.
GF into FI, which is adding up to 1, right? This is the whole pentagon's area, right?
Yes, correct.
So this becomes x square plus GF we just now figured out is 2x, right?
Right.
2x into Fi is equal to 1, right? Correct?
Yes.
And Fi we know is same as Nm, and Nm would be, we can write it as MC minus X, right?
Right.
Do you understand? That's what I'm trying to do, right?
Yeah.
Nm is same as Fi and Nm is MC minus X, and MC we already know is this much. So instead of this Fi, I can write 2 root 2 minus 1 minus X, right?
Right.
Now I get a quadratic equation on X, correct?
Yes.
So we are getting, so here we'll get a minus 2x square. So it will become minus x square plus 2x into 2 root 2 minus 1 minus 1 is 0, right?
Yes.
Okay, let's solve the quadratic to find our x. We will get x is equal to minus b minus of 2 into 2 root 2 minus 1 plus or minus root over b square. So 4 into 2 root 2 minus 1 whole square minus 4 into a is minus 1 and c is also minus 1. So 1 divided by 2 into minus 1, right?
Yes.
So 4 can come out of the root with a become a 2, and that can cancel here with the denominator everywhere, right? So it is minus of 2 root 2 minus 1 plus minus square root of 2 root 2 minus 1 whole square minus 1 divided by minus 1, right?
Yes.
The x cannot be negative, so we'll take the positive sign, right?
Right.
And this becomes root over 2 root 2 minus 1 plus 1. So 2 root 2 and 2 root 2 minus 1 minus 1. So 2 root 2 minus 2. So this is 2 times root 2 minus 1. Again, a 2 comes out and it becomes root of 2 minus root 2, right?
Yes.
And it is a slightly weird answer so far. Uh, 1 second. So what we need is fi square. What we need is basically fi square. So fi square, fi was how what for us? 2 root 2 minus 1 minus x, right?
Right. Yeah.
We need this square. Our x is coming out to be this thing. So let's look at it a little bit. I'll not try to simplify everything here. I'll just write this answer in a nicer way. So this is becoming, so minus of this by minus 1. So that becomes a plus only. 2 root 2 minus 1, right? And plus this thing by minus 1. So minus inside the square root, I will keep it as it is for now. 2 root 2
Yes.
minus 1 whole square minus 1. You can even square it out and simplify it. So it will become 8 plus 1 minus 4 root 2 minus 1, right? So
Right.
it is square root of 8 minus 4 root 2. Okay. And
Yeah.
outside there is 2 root 2 minus 1 minus, right?
Yes.
This is the solution of x from the quadratic, right? But what I
Right.
need is not that. I need fi squares. Fi was this, right?
Correct.
So notice that you have to do 2 root 2 minus 1, subtract from that x, which is having this term itself, right? So
Right.
it is going to be plus root over 8 minus 4 root 2, right?
Right. Yes.
And square of that is 8 minus 4 root 2. So that becomes your answer for fi square. Now remember what we have done here. There could be other ways to do it, but what have we done? We have said that this was the situation, perpendicular lines were there. All the areas were given. It was also given this is equal to this. So from here, we area 1, we got that this much is, how much was this part? It was root 2, I think, right?
Yes.
Root 2, this part was 2. And we drew the diagonal. And we know that the diagonal was having a total length of 2 root 2, right? And we said
Right.
that this distance x was actually 1 because this is also perpendicular. So what we got was our length of this part was 2 root 2 minus 1, right?
Yes.
And we did the exact same thing on this side. We drew this line joining and we said that this is x, right? So
Right.
this distance must be 2x and these distances must be root 2x, right?
Right.
Because it's the same figure that is being reproduced on that side, just smaller, right?
Yes.
We had to find this square. So technically all I need is this much, right?
Right.
Or I need the value of x because I already know this much is 2 root 2 minus 1, right?
Yeah.
After that, I did area of the pentagon was given as 1. So I made everything in terms of x and made a quadratic.
Correct.
So
Yeah.
area of the triangle plus area of the rectangle is adding up to 1. That gives you a quadratic. You can solve for x from there.
Right.
Once you get x, you need to find out not the value of x. You need to find out the value of 2 root 2 minus 1 minus x square,
Yes.
right?
Yes.
So the question is solved because this triangle is an isosceles right angle triangle and the other side also there is a similar situation happening. Obviously, there will be other ways to do the problem. However, this is an easy way to think about it at least.
Yes.
You could have tried just similar triangles directly and tried to do similar triangles between the big triangle and the small triangle there. That is also an approach. You don't have to solve the quadratic equation then. But again,
Okay.
calculations will be there, similar calculations.
Yeah.
Okay, what is the next one?
The next one was 23.
Okay. Uh, right. There is a square ABCD in the XY plane. Square ABCD in the XY plane. It has vertices at A 1, comma 1. Okay. Minus 1, comma 1. Okay, so the center of the square is the origin.
Yeah.
This is 1, comma 1. Then there is a minus 1, comma 1. There is a minus 1, comma minus 1. And there is a 1, comma minus 1.
Right.
This is my square. Each side has length 2. And let's label the points A, B, C, D. Okay. A, B, C, D. Now, consider the following four transformations. L is a rotation of 90-degree counterclockwise around the origin. R
Yeah.
is a right rotation, clockwise rotation around the origin. H is a reflection across the x-axis and V is a reflection across the y-axis. Okay. Each
Yes.
of these transformation maps the square onto itself, but the positions of the labeled vertices will change. For example, applying R and then V would send the vertex A to 1, comma 1 to minus 1, comma 1. Minus 1,
Right.
comma minus 1. So think of applying R and then V. R is a rotation clockwise. So about the thing, 90 degrees. So if you rotate like this by 90 degrees, this A vertex will start being where this is, right?
Yes.
This point A will come here, right?
Yeah.
And then reflection about y-axis would take it like this here, right?
Correct.
So that is what he's saying, right?
Yeah.
Now the question is being asked, how many sequences of 20 transformations chosen from this set of transformation would send all of the labeled vertices back to their original positions, right?
Right.
So one of the ways to do that would be RRVH is one sequence of four transformations, right?
Yes.
RR, two rotations of 90-degree clockwise, then VH. Let's think about it once. RRVH. Uh, so R is clockwise, V is reflection about which axis V was? Y axis, and H is across X axis. Y axis reflection and H is X axis reflection. Okay, so if I do R and then R, A will go to C, right?
Yes.
Because it's a 180-degree clockwise rotation, right?
Right.
Are you understanding what I'm saying?
Yes.
Then reflection about y-axis would bring C about y-axis. So it will come back to D, right?
Yeah.
And then about x-axis, D will go to back to A, right?
Yes.
So basically RRVH will bring the point A back to the point A only, right?
Right.
We need to find a sequence of 20 rotations that will, how many sequences of 20 rotations will not change anything basically, right?
Yeah.
Okay. Uh, right. Total number of possible sequences, 20 length sequences, would be 4 to the power 20, right? Correct? So
Yeah.
20 length sequences, there are 4 operations, L, V, R, H. Every step you can do anything. Number of possible sequences are 4 to the power 20 or 2 to the power 40. But we need only such sequences which will keep us at our same place, right? Right?
Yes.
So, uh, if you want to come back to the same place, uh, you have to have an even number of reflections, right? You cannot have an odd number of reflections.
Right.
If you do an odd number of reflections, you will definitely shift your coordinate, I think. Think about it. If you do one reflection, obviously it will shift, right? If you do 3 reflections, yeah, there is no way you come back to the same point after 3 reflections.
Right.
Do you understand what I'm saying?
Yes.
It has to be even number of reflections, right?
Right.
But even with an even number of reflections, you could end up in a different place, or at least a different, like you could end up with a different orientation at least. Because right
Yeah.
now it is A, B, C, D. Just after 2 reflections, you could go flip it by x-axis. A and B are here, and then flip it by y-axis. It becomes A, it goes here and B goes here, right?
Right.
Uh, 1 second. Hmm. Yeah. Okay, let's focus maybe on small sets of things. Like let's focus on 2 transformations. 2 transformations. What happens after 2 transformations? Any 2. So there are 6 such pairs of 2 transformations, right? So you
Yeah.
can do LV. L is a anti-clockwise reflection. So A goes here, and V is anti-clockwise rotation, and V is a reflection in y-axis, right? So
Yeah.
A would go from here by y-axis, y-axis. Okay, so it will come back to the same place then, right?
Yes.
After LV, you will come back to the same place. XY comes back to XY, right?
Yeah.
Are you understanding what I'm saying?
Yes.
After LR, what happens? L and R. L and R are opposite operations, so it will come back to the same place.
Right.
Do you understand?
Yes.
After LH, what happens? L will basically take it here and H will bring it down here, right? So XY goes to minus X minus Y, right? Correct?
Yes. Correct.
Then there is VR. So V is Y-axis. So Y-axis reflection will take it here. And R is a clockwise rotation, right?
Yes.
Clockwise rotation will bring it back here, right? 90 degree.
Right.
So here also XY goes to XY only. Then there is VH. V will take it here. H will bring it here, right?
Yes.
XY goes to minus X minus Y. And finally, there is RH. So R will clockwise rotate it to here and H will reflect it here, right? Do you understand what I'm saying?
Yes.
So notice that all the six options we have exhausted, right? Six possible combinations of two operations, right?
Right.
And you can see that out of the six, there are three options where it is untouched and three options where it goes to minus X minus Y, right?
Yes.
Correct.
Yeah.
So, uh, after this, another pair of transformations, if you apply, the same thing will happen again with the same probability, right?
Right.
Do you understand what I'm saying?
Yes, I understand.
So, so basically, so like if you apply two transformations, you are either ending up back at the same or you're ending up somewhere here, right? And
Right.
if you apply another two transformations, you will end up again back at the same place or somewhere here, right?
Yeah.
So there is a what is the probability that after two pairs of transition transformations you end up at the same place? That's what I want to find out. What's the probability? After applying the first pair of transformations, the probability that you end up at this is half, right?
Yeah.
And probability here end up at here is half, right?
Right.
After applying another pair of transformations, you could go from here to here, or you could go from here itself to here, right? how can you end up at A after 4 transformations, right? That is what I'm thinking about.
Yeah.
You could have been at C and then ended up at A from there. Or you could have been at A itself and ended up at A itself again, right?
Yeah.
So basically, if you were at C, you need the opposite transformations which take you to the opposite, which happens with the probability half. So the overall probability of that happening is 1 by 4 then,
Right.
right? And if you were at A, we are still getting 1 by 2 into 1 by 2, 1 by 4 from there also. I'm making some mistakes somewhere, I think. Um, hmm. The reflections, instead of a reflection, can we think of it as a rotation? The reflection across this is technically the same as a rotation, right?
Yeah.
But actually, the orientation gets ruined in a reflection. A becomes here, D becomes here, and B and C goes here, right? You would get a D, B, and okay, wait, it becomes a clockwise now. Earlier, it was an anti-clockwise ordering. Now it is a clockwise ordering after a rotation, after a reflection, right?
Yeah.
Uh, Similarly, reflection in the x-axis will bring A here, B here, and C and D here. It will become like this now, A, B, C, D. And um, yeah, I have to think about it right now. I'm not getting the whole, maybe I'm not calculating it correctly. The probabilities only was better. Um, is there any other problem that is a doubt here in this paper?
Uh, after 23, it was 25.
Second. Basically, in this one, they are saying a positive integer is written as the product. The fi and integer is strictly greater than 1. They are written as a product of the factors, basically. Order in which the list factors are listed matters. every different listing is counted, right? So 6 is written as 6 or 2 into 3 or 3 into 2. And D of 6 is 3. They're asking you for D of 96.
Yes.
Okay. So 96 is 2 power 5 and 3. Uh, this will be some casework where you have to figure out how many ways to group the 5 twos and 1 3. How many different arrangements are there, right? 5 twos and 1 3. If you after that, you have to figure out you need to multiply any two of them and the remaining to figure out the factors, right?
Yeah.
What have you tried here so far?
Uh, so for this one, it says like they're integers basically. So like I was thinking because it's asking what D is 96, I tried to do the prime factorization of 96. So like 2/5 times 3. That's what I got for the prime factorization. And then
Mhm.
like
You need to first say that how many factors you have. The number of factors you have could be starting from one factor, simply 96, right?
yeah.
Then you could have list of factors where there are two factors are multiplied, 2 into 48, 3 into 32,
Right.
4 into 24, 6 into
Yeah.
16. Then there will be 8 into 12, right?
Right.
8 into 12. After that, there will be 12 into 8, right?
Yeah.
After that, the reverse of all of these, right? But
Yes.
the main idea is that there are two factors being multiplied here. There was one factor being multiplied here.
Mm-hmm.
Similarly, you could have written it in terms of three factors, four factors, and so on, right?
Yeah.
We want to add up all the possible ways. So you need a general solution where if there are k factors, what are the number of ways, right?
Right.
Do you understand what I'm saying?
Yes, yes.
So, so if there are k factors, how many ways can you do that? You need to count that, and then we will have to add up all the k's. K can be from 1, 2, 3, 4, and so on,
Yes.
right?
Yeah.
So you know that since 96 is 2 power 5 into 3, the factorization definitely has to have one factor that is a multiple of 3, right?
Yes.
So there are k total factors, so there are k ways to choose that one factor, right?
Yes.
So now you are left with k minus 1 slots, which must contain at least one factor of 2, right?
Right.
Do you understand what I'm saying?
Yes, I understand.
You have given 3 to one of the factors, where k choices for 3 to go to, right?
Yeah.
And then after that, you have to figure out where the 2's will go in the remaining k minus 1 slots, right?
Right.
Correct?
Yes.
So if there are k minus 1 boxes and you have 5 2's that you can give out, right?
Yeah.
You can give it like this also, 2 2 2 and so on, or you can give more 2's to one box, right?
Right.
Each box can have greater than equal to 0 2's, but the total must add up to 5. Do you understand?
Yes.
This is stars and bars method. Total is 5 and every box can have greater than 0, right?
Yes. Right.
And there are k minus 1 boxes, right?
Right.
So you can, every box can have 0 or more than 0. Uh, Actually, every box must have 1 1 2 for sure. The reason is because we are saying there must be k factors.
Yeah.
If there was one factor missing, no 2 here, then that factor only is gone. No?
Correct.
Do you understand what I'm saying right now?
Yes, I understand.
There are k factors. I have given one of them a 3. So that is going to be present. And now that was done in k ways. And all of those factors, now k factors, I have to supply 2's to them, right?
Correct.
But I have to give 1 1 2's to remaining k minus 1 for sure. 1 1 2, right?
Correct.
Because if I don't give 1 1 2's to these ones, then if 0 2's are there, there is no other prime factor to supply, right? So then the
Right.
factor itself will be gone if I don't give a 2 to it at least, right?
Yes.
So k minus 1 2's have already been taken out of the 5 2's, right? So 5 minus k minus 1. 6 minus k 2's are left now, right?
Right.
Correct?
Yes.
These many 2's are left, and these 2's have to be given to the k minus 1. Now, this 6 minus k factors of 2 are to be assigned to the remaining k factors, and this is directly stars and bars. 6 minus k n plus r minus 1. So plus k minus 1 c r minus 1. That should come plus k minus 1 c k minus 1.
Yes.
So this becomes a 5c k minus 1, or 5. This is becoming 5c k minus 1, or you can write it as 5c6 minus k. That is going to be the same thing. You could have written it as n6 minus k plus k minus 1 c6 minus k, right?
Yes. Yeah.
Basically, that gives us how many ways can we put in the prime numbers to it so that we have k factors total. So the total possibility is k times 5c6 minus k. Why have I multiplied with k? Because 3 could have been given in k ways.
Right.
After that, we have done the calculation of how many ways can you give the 2 power 5 out, right?
Yes.
Always ensuring that there are k factors in this case,
Right.
right? Now we
Yeah.
have to do the sum of this when k goes from 1 to 6. Because after that, you can't have more than 6 here.
Right.
Sum of k goes from 1 to 6. You have to do k times 5c6 minus k. After that, the combinatorial coefficient only doesn't make sense. You cannot have 7 factors here.
Yes.
So this is a direct calculation now. Let's put 1. You will get 1 into 5c5. Notice that the answer is 1, which makes sense because there is only one way to do 96.
Yes.
If you put 2, you get 2 into 5c4, and 5c4 is 5, so there is total 10. And you can see after this 5, after we have double them, 10 factors.
Yes.
Do you understand what I'm saying?
Yes, I understand.
So the main step here is to count how many factors are there, and for each number of factors when you have set, after that, how many ways can you give out the 3 and the 5 twos to them to construct the numbers, right?
Right.
Obviously, 3 could have been given out to any of the k. So there are k ways to give out a 3, right?
Yes.
And how many ways do you need to give out the 5 twos in order to maintain the k factors, right?
Yes.
So one of the factors is already non-zero, not going to be 1 because it has been given a 3. You have to give the 5 twos to the remaining k minus 1, right?
Yes.
You need to give out 1, 1, 2 to each. Otherwise, if you don't give out 1, 2, then one of the factors will become 1 then.
Right. Okay.
So if you already give out 1, 1, 2s out of 5, you say 5 minus k minus 1. This many 2s are left, right?
Yes.
6 minus k 2s are left. And they have to be, now there is no restriction. These can be given to any of the k factors.
Right.
Do you understand what I'm saying?
Yes.
6 minus k 2s have to be given to any of the k factors, that is stars and bars. That will come 6 minus k plus k minus 1 c k minus 1. So now we have figured out how many ways to give out all the 2s now. Multiply that by k, that is the number of ways to give out 3, and you get k into 6. This thing is the number of ways to construct these factors.
Right.
And k can be 1, 2, 3, 4, 5, 6. And then you simply add up all of these cases, then you will get the answer. Summation of k goes from 1 to 6, k times 5c 6 minus k. So basically calculate each of the situations, you will get an answer simply down.
Right.
Do you understand what I'm saying?
Yes.
There possibly will be other ways to do, like direct calculation is also possible. We just saw k is equal to 1, we got 1 way, k is equal to 2, we got 10 ways, right?
Yes.
Then you can also think of how many ways can we make 3 factors such that they multiply to 96, right?
Right.
But the direct counting way will be slightly annoying to do if you do a direct count like that. Because 3 factors, you have to think of how many 3s and how many 2s, which ones will you give, and so on. It will be a little more difficult to do direct count. Okay. So the problem in this that is unsolved is 23, right?
Right.
The rotation and all, yeah. Okay, I'll think about it. Uh, Try a couple other papers, some other papers, whichever you feel. You have done all the 2021 onwards, right?
Yes.
Okay, so try a couple more of these papers. I'll think about that 23rd one. If I get it, I'll tell you.
Yeah.
Okay, fine. That's all for now then. We'll discuss in the next class. We'll continue with number theory in the next class.
Okay.
Bye.
Bye. Thank you.